Okay, ji Bismillahirrahmanirrahim. Assalamu alaikum, dear students. So today lecture is about the symmetry and skewness. And as you can see in the figure, you are having three figures over here. The central one is known to be the symmetrical distribution. Why so it's called to be a symmetrical distribution? It's equidistance from its edge. What the equidistance from its edge is? The center line. And at the center, we are having the mean, median, and mode. The all three famous measure of averages are coincide in case of the symmetrical distribution. So whenever we have a data set in which we have to calculate the mean, median, and mode, and all of them are equal, then we can interpret that this is a symmetrical distribution, like this distribution. If you would like to draw it according to like we have done for the histogram. So this kind of curve we will get for the symmetrical distribution. This have the equidistance from the edges. Edges mean from lower tail to upper tail. And now the two more figure we are seeing over here, the right one and the left one. The right one is called to be the positively skewed distribution because it's having a longer tail on the right side. And here we have it a longer tail on the left side. So this is called, the blue one is the positively skewed and the left one is called the negatively skewed. In the positively skewed distribution, the mean median mode having the relation like mean is greater than median is greater than mode. Whereas the left tail distribution, the negatively skewed distribution, the mean median mode having the relation like mean is less than median is less than mode. And if we are on the symmetrical distribution like this green one, then there is no skewness. But if we have such kind of distribution, the orange and blue, then it's known as to be the asymmetry, lack of symmetry, positively skewed or negatively skewed. Skewness is existing over here. Skewness mean lack of symmetry. The data is pulling towards due to some very reason on the right side or the left side. So this is the case of the skewness. Now we have to read something about that. Symmetry and skewness. What does it mean? The distribution is symmetrical when the values of mean, median, and mode are equal, as we have seen in the green one. Whereas the skewness measures the extent to which the observation are asymmetry, lack of symmetry. Fine. The second term is if observations are symmetric around the mean, there are as many observations less than the mean than there are observations greater than the mean, like the equally distributed data. So this is the same definition of the median. So that's why it's confined. And it's a over here. Why the mode is over here? Because this is the highest frequency having on the same point. So mode is also existing over here. So that's why it's a mean median mode coincide over here. This is the very reason. And here, in other words, skewness tells us whether there are many more observations above or below the mean. So according to mean, we have to measure how many distributions are above and how many distributions are below. Okay. So like mean, skew is sensitive to extreme value. If there are extreme values, certainly, so skewness is more on the either tail. It's depend on the value. If it's a positive values, which are having the extreme values or the outliers in the data, then it's a positively skewed distribution and vice versa. And here, if there is no skewness, like the symmetrical distribution, it's equidistant from the mean, so skewness is equals to 0. Then it's a left skewed and it's a right skewed, which we have already discussed. It's the same thing. It's over here. The mean relation, we can say the positively skewed distribution, there is a longer tail on the right and the mean is on the right of the mode. Like mean is, you can see from minus infinity to plus infinity we are going. So mean is at the extreme one. So mean is greater than median is greater than mode. Median always lie into the mid, obviously. It's divides the data into the two equal parts. So in the positively skewed, you have this relation that mean is greater than median is greater than mode. And certainly in the negatively skewed distribution, you have the relationship mean is less than, median is less than, mode. Excuse me. Now, skewness is positive or negative depending upon the location of the mode with respect to mean. So it's an important point because median is always lying in between them. Measure of skewness. So how we can measure that as symmetry? Okay, if it's a symmetrical distribution, then we do not need to measure it. It's going to be a 0. But if it's there is a skewness, so how much it is, how much the observations are apart from the mean, and it's how much observations are larger than the mean and the smaller than the mean. So we need to give a numerical measure to that. So shows the degree of a symmetry or departure from symmetry of a distribution. It's measure of skewness. It's a work of the measure of skewness. Also indicate the direction of the distribution. It's a positively or negatively. So there was a statistician named to be the Carl Pearson. He has given us the two formulae. It's known to be the Carl Pearson first formula, in which you can say SK stands for skewness, and skewness can be measured with respect to mean, mode, and standard deviation. So mode is intermediate. My dear, sometime in the case of ungrouped data, if we talk about that, so there is sometime this is disadvantage, no mode distribution. Sometime there are two mode distribution. So mode is not that much unique. So that's why Carl Pearson has given us one more formula for skewness. It's known to be the second formula. And here we are having 3 times mean minus median over standard deviation. So there is no mode. You are using the relationship between them and just turn it out into the second formula. Although the two formula have to give us two different results, but the interpretation will be the same. What does it mean? Mean, we are having mode here. We have calculated the mean, median, mode of a distribution and just substitute over here and the standard deviation as well. And substitute over here the values. The values will can be vary, certainly. But the trend has to be the same. Means if we get the positive answer over here in the first formula, then similarly we will get the positive answer over here, and the vice versa. Negative answer for the first formula, then negative answer for the second one. Means they have the interpretation has to be the same. Now, what is the limits over here? SK lies between -3 to +3. So this is the range of the skewness, the formula designed by Carl Pearson. They said skewness is greater than 0, mean positive hoga, to kya hoga? The distribution has to be interpreted positively skewed. And we can interpret the relationship between mean is greater than median is greater than mode. Similarly, for the skewness is less than 0, means अगर हमारी value इन दोनों formulas की negative आएगी, so हम कैसे interpret कर सकते हैं? This is the negatively skewed distribution. So the mean is less than, median is less than mode. And the third situation occurs if skewness comes out to be 0. If with the help of first formula you get the 0, then it is certainly you will get 0 with the help of second formula for a particular distribution. I'm talking about for the same distribution. G, my dear. So greater than ka matlab positively skewed, less than ka matlab negatively skewed. If we get 0, then it means symmetrical distribution. There is no skewness. No skewness means what is the relationship between the mean, median, and mode? That they are all equal. If for a particular distribution you get 2.5 kilogram for the mean, certainly you will get 2.5 kilogram for median and 2.5 kilogram for mode. Same answer you will get it for all three measures. So it seems there is no skewness. Now, my dear students, we have to do one practical example for that. Look at here. As give the following statistics on weights of the court justice in kilograms, calculate coefficient of skewness using Carl Pearson method. So we will utilize the both formulas. We have the calculation, mean, median, mode, and standard deviation. Just we need to substitute the values and we will get the result. The same thing which I was interpreting in the formulas, that due to the calculation, Zahra, either we are using mode, here we are using median, the answers can be very numerically, but the interpretation is same. If we get less than 0, so it's mean we have negatively skewed distribution. And the same answers, the same interpretation, sorry, we get it over here, that negatively skewed distribution. And we can interpret that the mean is less than, median is less than mode. And here the same, the mean is less than, median is less than mode. So the interpretation will not be vary by the two formulae, but certainly the numerical value can be. So now here I'm stopping it out.
Thank you very much for watching my video.